Welcome to Brain Vision.
Okay, so we have a calculus problem involving a helicopter, and we, for some reason, very precisely know its position vector as a function of time, and they tell us the weight in newtons. So let's actually go ahead and convert this into a mass right off the bat, because mass is more useful than weight. So we just do that by dividing the weight by our local gravitational acceleration of 9.81, and that gives us a mass of 2.80 times 10 to the fourth kilograms. Great, that is a much more useful number. And then again, we know the position vector as a function of time very, very precisely. So I'm going to suppress the units for elegance, but be rest assured that everything is in SI units, so we know that it all works out. We have 2.2 t j hat over here, and then, oh, sorry, that's a minus sign. 0.060 t squared k. And we basically just do calculus to this in order to find, take two time derivatives in order to find the acceleration, so that we can then multiply it by the mass that we just solved for in order to get the force. So we're going to take one time derivative. So 3 jumps out in front. So this becomes 0.06. This t just disappears via the chain rule. And then this one, the 2 hops out in front. Great. So that's velocity. And now we do the same thing one more time in order to get the time derivative of velocity, which is acceleration. So now this 2 is going to jump out in front. The middle term actually disappears because it was a constant. This one will also be 0.120. That t just disappears. Great, so that is the acceleration. And then now we specifically want to find the acceleration when t is equal to 5 seconds. So we plug in a value. Sorry, seconds, we plug in a specific value for acceleration and get 0.600. In the I hat direction, and then this stays the same in the k direction. Great. Now we are ready to find the magnitude of the acceleration by using the Pythagorean theorem. We saw that the y component already disappeared, so that's going to go to 0, and then we just need to take the square roots of the sum of squares of the x and z components. So that was 0.6, and the z component is negative 0.12. The minus sign will turn out to not matter because we're squaring it, but we do that anyway. Add them together and then square root it and get that acceleration. So now we can do Newton's second law to it in order to find what the force at that exact moment in time was. So now we can use the mass that we already solved for, multiply it by the acceleration that we just solved for, and then get a force of 19,900 newtons. Quite massive because it's a helicopter.